All right, we're back in person. Yeah, this is pretty cool. So we have some upcoming events. I'm just going to kind of mention them right now. We do have a networking event in Alt Space on the 17th. It's Thursday evening. And next month we have Dr. Bering Keshavars, who is one of the foremost experts on motion sickness in simulated environments. And he's going to share his research with us. Definitely come by, check that out. That'll be a Zoom event. And I just want to thank our sponsors, XRTerra and CIC. Just going to have them each give a little blurb.
Hi everyone, my name is Emmy. I'm with CIC, Cambridge Innovation Center, which is the space we're all in right now. And I'm an event planner for them. So I've been working with BostonVR as well as one of my colleagues to help coordinate this event. If you're not familiar with CIC, it stands for Cambridge Innovation Center. We're a co-working space here at Kendall Square, but we also have locations all over the world. So we're in Tokyo, Warsaw, Rotterdam, and all over the US too. Our goal is to bring people together and try to foster collaboration and innovation between all different industries and all different fields. One of the ways that we do that is through our event program. So we host events for our clients, sometimes collaborations for like nonprofit mission-aligned groups, for our staff, and then just for the greater Boston community. So if you're interested in learning more about us, our website is just cic.com. Pretty simple. Yeah, but thank you again for coming out, and I hope you enjoy what these folks have planned for you.
Hello, y'all. My name's Greg. I work for XRTerra. I'm one of their instructors. XRTerra is a boot camp. It's a VR AR boot camp that teaches you how to develop VR and AR. Just wanted to let y'all know that the class that I am teaching is starting in a couple of weeks. I think it's the 21st that it starts. And it's a boot camp that will take you through the process of developing a VR application. And I'm teaching it, and it's everyone in this room, I think in BostonVR, can get a $1,000 discount. I think that it ends up totaling to $2,500 for the course itself, but just want to let you all know that's available. I'm teaching the course. It's super fun. I'm very proud of it. And XRTerra is glad to be here. I'm very glad to be here.
All right, Nano.
Take it away. Alex, who are you?
Oh, I'm Alex. I normally like to.
Microphone, but the simulcast.
Oh, it's actually picking up pretty well. I threw my headphones on over there. I'm Alex Bernstein. I'm doing some event coordination. If anybody wants to give a demo, tech tutorial, has ideas, please reach out. It's alex@bostonvr.org.
Take it away.
All right, so every once in a while, there comes a invention that really changes everything. And in the case of the 16th century, this was the invention of the microscope.
Oh.
And
Can you share on the Zoom?
oh, sorry about that. Man, I was gonna make it a dramatic intro.
Oh, sorry.
All right, pretend like you didn't hear the last 20 seconds.
Oh, sorry. I thought you would.
What did you say? You were muted.
Oh yeah, I was muted, right? All right, cool. So every once in a while, there comes an invention that really changes everything. And in the case of the 16th century, there was an invention known as the microscope that led to a bunch of scientific breakthroughs. You probably know about this. And so as a result, we know that visualization drives scientific insight. But did you know, and this is a fun fact that I learned by working at Nano, which is that in the beginning, the microscope was actually a toy for the affluent and rich people. And so it wasn't actually until 60 years later, after the invention of the original microscope, that it was used for scientific purposes, and the microorganism was discovered. And so 5 centuries later, we actually see a similar trend with virtual reality, where virtual reality, at least this iteration in the 20 teens and beyond, is primarily right now a kind of a entertainment device for the Apple, especially if you go back to like 2016, 2017, when you needed a powerful gaming machine to run virtual reality. And of course, this is already outdated, and you could tell that this was a pre-COVID presentation because this was $1,000, and now you can get a Quest 2 for $300, right? So obviously the trend is downward, but again, still definitely not necessarily a massively available device yet. And so, I'm kind of preaching to the choir here at a VR meetup, but we truly believe that the spatial computing, or AR and VR, or XR, MR, metaverse, et cetera, is going to be the next computing interface. We went from mainframe computing to personal computing to mobile computing, and spatial computing, we believe, is kind of the next iteration. And that is to say, what's important to note is that we really don't think about it as substitutionary. We think about it as complementary. Like, I carry an iPhone and a laptop and an iPad, well, I don't carry a mainframe computer anymore, but you kind of generally get the point. And so we all know what the future of scientific visualization looks like, right? If you ever looked at Iron Man, and like Jarvis, Tony Stark, or even like other different types of sci-fi films, there's usually like a scene where there's like a holographic periodic table, and then they're like, oh yeah, what if we combine this molecule and like we put a DNA in there and stuff like that. And so we're building that. Yeah, my name is Keita Funakawa. I'm the COO and co-founder of Nanome. And that's kind of what we do. We're trying to build like this Jarvis future crazy science interface, starting with molecular data, and it accelerates existing computational workflows in science, as well as enabling more scientists to actually gain access to these types of different simulations and powerful computational tools. And so Nanome is the world's first intuitive interface from the atom up. We really like to say 1 to 100 nanometers is our sweet spot. And I'll talk more about that later, but really there's a bunch of different types of industries that are applicable here. What's really cool is that latest like Apple silicon chip is 5 nanometers for each feature set, and which is about the size of 5 to 7 Tylenol molecules stacked together. And so, really, if you look at different types of industries, they're dealing with different parts of the periodic table. If you look at the periodic table, it's kind of like a palette, if you will. And so we have kind of this potential to disrupt all molecular industries. And so today, we're really focused on drug discovery and life sciences. We're in Cambridge today. It's actually a really great area. We're based out of San Diego, and so it's really awesome to be in kind of the counterpart on the different side of the coast here. And so we have kind of these 3 pillars that we pride ourselves on that really makes us differentiated from different 2D tools and 3D glasses and things like that, which is one, it's highly intuitive. You all know this. You can grab a molecule, you can be like, oh my God, I literally can hold a molecule in my hand. Second, it's collaborative, which has been a huge highlight throughout the pandemic, is that you can have multiple people in the same virtual room collaborating together as if they're actually across from me on the table. And lastly is that we have a very flexible Python API that allows people to use different types of computation. So if you ask the top 10 pharma customers or companies on what kind of simulation algorithms they prefer, they'll give you 10 different answers. We're not trying to replace those. We're trying to integrate with the existing workflows. And so for those of you who aren't familiar with life sciences or drug discovery, there's a huge list of things that it takes to get a drug to market. Takes typically about 10 years and $2 billion+. Currently, our sweet spot is in more on the early stage drug discovery side of things. It's really funny because people are talking about the metaverse and how why would anybody want to not be in real life or whatever. And I can tell you that these scientists that are on the left side of this chart here really love to spend a lot of time in the virtual metaverse of testing molecules, because once they start actually testing in the physical labs, then they actually have to work, right? And so these are scientists that are already spending tremendous amounts of time really thinking about how these molecules interact in a virtual sense. And so we have some really awesome features that allow you to do some very complex manipulations at the molecular scale. These are just some examples. Collaboration is a huge thing. We kind of already went over this. And then the Python API that I just mentioned is a really great way to have very extensive backend calculations that are available. Some of you might know about AlphaFold that just came out, which made a kind of a breakthrough in life sciences. We have an in-app web browser, and so you can like pull up AlphaFold, pull up any protein theoretically that's computed by AlphaFold and then bring it into this virtual space, which is really cool. So the next step is really getting those voice integrations so that you can be like, all right, AlphaFold, like how about this protein? And then it just gives you that. We're not quite there yet, but we are going towards that direction. And so actually I just kind of skipped ahead a little bit here. So this is the kind of a deeper example of the web browser, different things that you could do. There's a bunch of like 2D web apps that scientists already prefer to use. And so again, we're not trying to replace those. We integrate very closely with them. There's this really amazing feature that we made called spatial recording. And basically what that allows is a user can record their experience within our environment and then later play it back. But not only can you play it back, you can pause and actually interact with that data later. And so, the code name internally for our company was Luke, Your Only Hope, because, that scene when like Leia's talking to Luke and like, oh, like this, do this with Obi-Wan or whatever. Like you can kind of do that. And in fact, we have pharma customers that use this feature to cross collaborate. One of our biggest customers is Novartis, and they have a site in Basel, Switzerland, Cambridge, Boston, and in San Diego. And instead of somebody waking up at 6 a.m. in the morning, you can actually have an asynchronous collaboration with these recorded holograms, which is really awesome. So highly recommend checking that out as well. Right now, it's like, these are all the features, that's awesome, but like, is it actually useful, right? Nano has, and VR has meaningfully impacted the scientific discovery process already. So these are just some of the testimonials that our customers and users have said before, which is that, it's the next quantum step, new generational leap. It could save chemists like 3 to 6 months of their time, which, again, $2 billion, 10 years, 3 to 6 months is worth whatever, do the math, it's millions of dollars at least, right? Also the very important thing is in life sciences and drug discovery, going down the wrong path is very expensive. And you want to figure out that you're going down the wrong path very quickly. And that's what they call time to kill. So really having that intuition, getting that understanding in virtual reality so that you don't make those mistakes in physical reality is something that is hugely useful. We've had companies that like Nimbus Therapeutics, which I think is like somewhere across like a couple blocks down. Nimbus Therapeutics like changed a therapeutic vector because of Nano. They realized something in the virtual space that they found out, and they were like, wait a minute, we need to take a completely different direction here. And so we did this case study with Oculus for Business and Nimbus Therapeutics. Definitely check out that full case study there. One of my favorite things about this, again, it's not just about getting the expert users in this virtual world, it's also about getting more people to understand this data because of the fact that you get much better intuition. And so this is a paper that we published with Novartis talking about how structural analysis can be democratized to general scientists, which in turn fostered novel collaboration ideas and findings. And this is actually one of my favorite quotes. So this is our first customer from UC San Diego. We spun out of UC San Diego. He said he's had like experienced scientists that have been staring at their molecules for decades. They took one look at their molecule in VR and Nano, and they're like, oh my God, I didn't realize there was so much space here, that this active center could be like that big over there, things like that, which is just kind of crazy. I mean, these people literally wiggle their mouse on a 2D screen for like months on end just to get a better intuition for their structures that they're working on. And VR is just a huge game changer for them. And last but not least, had to mention our COVID efforts. We have government research labs from Australia to local government research labs like Oak Ridge National Labs, Italian biopharma companies, like a lot of different companies that are actually working on COVID research use our tool, which we're incredibly proud of. And kind of the breakthrough recently, this was a paper that was published just a few months ago, which is that Oak Ridge National Labs used VR and Nano to design a potential antiviral compound that could actually treat COVID. And so I think many of you have probably heard of the Pfizer antiviral drug. This is kind of a similar idea where you're treating COVID, it's not a vaccine, right? So, and the fact that a novel compound was designed in VR was kind of mind-blowing and really awesome. So where to find Nanome? I think this is already in the meetup link. So you can actually, we're one of the few apps of our kind that is used in Top Pharma, but you could just download it from the App Store. And so unless you're actually trying to make $1 billion drug, you could totally use our free version and get a really good understanding to like build molecules and stuff. One of the great things about this is that if you've ever used a organic chemistry kit in high school or university, it's like that, except you never run out of parts and you can apply these crazy simulations, right? So really cool to be able to have that. And so just a quick segue into, that's what I just talked about is like Nanome today. I wanted to quickly talk about, the future of Nanome and beyond drug discovery and the science metaverse. And so, we're very, very excited about mixed reality. A lot of people, especially scientists, like they're working with whiteboards, they're working with 2D monitors. They don't necessarily want to be in a completely different virtual world. And so, we've seen a lot of cool stuff come out in the last quarter or two, from Oculus to the Vario XR3. And there's just a bunch of amazing things that are happening in this space, and we're really continuing to pay attention here. And so these are just some of the demo experiences or kind of like prototypes that we have. It's not available just yet, but we will be definitely working in this direction going forward. And also, I mentioned this earlier as well. It's just that molecular doesn't just mean organic or biological. We have this vision. In 100 years, you want to go to Mars and you want to 3D print something. You're going to actually use Nanome to design something from the ground up, atom up, and doesn't necessarily have to be a new drug. It could be inorganic. Material science is a huge thing. The new Tesla Cybertruck uses like next gen technology, like cold pressed metal or something like that. That's all metallurgy, material science. You're looking at the atomic structures, crystal lattices, and things like that. There's not as big of a need as the biological side of things or the organic side of things, but that's something that we think is going to be huge in the long term. And this is actually something that I wanted to share very quickly. This is a testimony from one of our users. We have if you download Nanome, you'll see that there's a public lobby area that you can go to, and you can see other people's rooms that are available. And so it's kind of like Zoom crashing, if you will, or but better. The scientist from University of Sydney, he gate crashed the Swedish professor's room and just started up spontaneously talking about their research, and now they might actually start collaborating with each other, which is like kind of a crazy idea. These people would have never met without this, right? And so, again, we think ourselves not just into an ultimate interface to scientific data, but also to the scientific communities, right? And so it's kind of crazy with like kind of the whole metaverse talk that we've been having there. This is a quote before Meta rebranded to Meta, this idea of the scientific metaverse is very real, and it's already kind of organically happening within Nanome, which is really awesome to see. And the name Nano means the world of nano, and that could also mean the world in which you meet different colleagues and things like that as well. At the 2020 Facebook/Meta Connect conference, one of the proudest moments was when they featured us. This was like the height of the lockdowns, I think during the second wave in October. And they said that scientists are doing collaborative drug discovery from their homes, and that we need this right now. And so I want to leave you with that we truly need more science, and we truly need more collaboration. And so, as egotistical as it sounds, I truly believe that the world needs Nanome right now. Thank you very much. Cool. Is it questions time?
Yes.
Yeah.
So I've seen some molecules are animated. I don't know why. So that's my first question, I
Yep.
guess. And the second question is that something you've done in Nano?
Yeah. So there's a Richard Feynman quote that's like everything is wiggling and jiggling, and all the time. And so those protein structures that you can load up most of the time in Nanome right now, in reality, they're not static. They're constantly wiggling and jiggling. And so those are called molecular dynamic simulations or trajectory files. And we can load those into Nano. And so you're basically kind of theoretically simulating, all right, if there's a protein here, how does it kind of wiggle, and does this site change like so or whatever? And so that's actually a great point that you bring up, because, technically, depending on how you want to think about dimensions, it's either a 4D file or a 6D file. that you're trying to look at typically on a 2D screen. And so the fact that you can gain another dimension in VR, and so you don't have to like constantly, because these people were wiggling their mouse to get a understanding for a static 3D file, and then some people were even trying to do that on a moving 3D file, right? And so kind of closing that gap with VR is a huge deal for them as well.
We have a question from the Zoom.
Yeah.
Jake asks, how does the recent advances of VR impacted your company's vision?
Great question. I think from the we started in about 2014, 2015, and we officially incorporated in 2016. So we definitely saw the, it was right after Facebook bought Oculus and stuff, and we thought that this entire industry was, coming together. I think the advent of the Quest was huge because of the portability, the wirelessness, and accessibility. Because when we started that one paper that I cited that we co-authored with Novartis, that was they actually had 4 VR stations with desktops, and they're like, this is a VR room, and we go to the VR room in order to do VR things, and that's no longer a case anymore, right? That people have personal headsets, or we're trying to get people to get personal headsets, which is actually now physically possible. Now it's more of a logistical problem than just a pure hardware or IT problem. And so I think that's been a huge kind of accelerant, if you will. And then I think the next thing, and I briefly talked about this, which is the mixed reality aspect. And so, even though the people are when we were just at a conference earlier today, and they see a molecule in their hand for the first time, and they're like, oh my God, it's amazing. But I still really want to see the real world, right? And so the mixed reality aspect in recent advances, to those people, we can now show a prototype and be like, here's faster, here's what's coming in the next few years or whatever. And they're like, okay, this is amazing, I'm sold, right? So I think that there's kind of the recent past, the advent of the all-in-one standalone devices, and then there's the kind of the actual recent last few months recent, which is the mixed reality. And so those two things have been huge for us. Should I go clockwise? All right. Here.
All right. It looked like you mentioned that there's the ability to record a session,
yeah,
and play it back.
Mm-hmm.
Is that only on the headset, or is there a way to translate that into some kind of 2D screen for other people to play back as well?
Yeah, great question. So we actually have a 2D mode of our app where if you have a Windows computer, it has to be Windows, unfortunately, but for now it's Windows, and you can basically, it's like a first-person shooter where you can do WASD and then move around and stuff. And so we actually make a lot of YouTube videos where we screen record the first-person view, and I get to be kind of like a virtual cinematographer and move around a camera. Yep. And then we publish on our YouTube. So if you check out our YouTube, youtube.com/Nanome, it's very scientific and kind of domain specific, but there's a bunch of videos in there. Yeah, so the recording, you have to make the video kind of manually, if you will. You can't just press a button and there's going to be automatically video, but it's totally possible. We also have a built-in screenshot tool, so there's a virtual camera that you can bring up and do still images too.
You mentioned you have API for working with your app.
Yep.
For non-science people, what kind of software and apps are scientists connecting with?
So what's interesting is that on the scientific front, basically, but I guess your question was on the non-scientific.
Well, for people who aren't well versed in those sciences, how would you describe the workflow, I guess?
I guess scientists really want to look at all kinds of different types of analytics and informatics or simulations. What I was saying, the top 10 pharma companies prefer 10 different simulation algorithms. And especially because quantum computing is very young still, it's not industry adopted. And so as a result, these classical computers have very different ways on simulating how, what actually happens at the atomic level. And so and also depending on if you're trying to design a small molecule versus a peptide therapeutic, right? There's different ways in which you can optimize the simulation to give you an optimal result or not. And so those are usually the kind of the personal preferences that the scientists have that we enable them to be flexible with the API. Does that make sense? Yeah, and then beyond that, actually, like most of our developers don't have science backgrounds, and so they've made a Wordle plugin, they've made a Minesweeper plugin, like so it's really flexible and you can do a bunch of things with it. Yeah.
I gave it a try earlier today. Had a great time exploring things that I have no idea about. So it was a lot of fun, one on the tutorial side. And that got me thinking, it looks well done, especially for, I would assume, a port, right? I imagine you made this for PCBR originally and moved it over to Quest. It got me thinking, what is your team made of? Like, what's your team size? What are some of their talents? And ultimately, how did you port it to Quest and get it so performant?
Yeah, so our team makeup is about, like, we have, I want to say about 12-ish people on the development side and another 12, 15 on the sales and marketing side of things. And when I say sales and marketing, scientists are also in that bucket. And then the rest is kind of like the founding team. We have a pretty big founding team of about 4 people. And so the total team makeup is about 30. The kind of a lot of the sales and marketing personnel we hired in the last 2-3 years. We got some venture funding at the end of 2020, and so we're using that money to really expand our sales efforts and whatnot. And so to answer your question about porting to Quest, what do we need to optimize? What does it mean to actually develop on Android architecture and that kind of thing? And so those are kind of all the things that I guess time is kind of my answer, because it wasn't a plug and play, like, here you go. It was, months and months of R&D and making sure that we can do it. I would caveat that it's not necessarily one-to-one porting in the sense that the atom count is significantly still higher on the PCBR than on Quest. And so it's like if you played like Robo Recall, like you can tell that the polygon count is like much higher on the PCBR than on Quest. And so it's kind of a similar thing where you have to drastically lower it, but for the most part, it's still sufficient for a lot of scientific use cases.
Excellent.
Yeah.
So you mentioned organic chemistry. Could you be used to teach students organic chemistry?
Yeah.
And what about anatomy?
Yeah. So I swear I had a slide on this, but I guess I skipped over or I didn't talk about it too much. But we have over 250 universities that have actually downloaded Nanome, and some of them actually have gotten like classroom bundles and things like that. So like I said, if you wanted to replace the classic ball and stick model with this kind of virtual world and that never runs out of parts, like you could totally do that. And we have educational like teachers and researchers on the academic side both use it. I forgot what your second question.
Anatomy?
Oh, anatomy. Yeah. So I mean, I would say that we're not particularly like focused on kind of the bigger side of things. So we're very focused on kind of the molecular scale proteins. I think the biggest thing that we've loaded is like an entire viral capsid on the outside kind of thing. So which is still incredibly small, right? And so we do want to work ourselves up. I think like when you want to like look at a bone and then be like right click, look at the atomic structure, right? Like that's kind of where we want to be. And so I was kind of making a metaphor there, and we're not quite there yet, but I think that's another thing, right? It's, with all this metaverse talk, if you were to zoom into, let's say, if I were to create an exact replica of this, and like I zoomed into here, it would just be like a texture with a color, right? It wouldn't be any physical properties to this thing unless you actually apply like physical assumptions to it. And so we want to build kind of a metaverse, if you will, that is atomically precise. So when I go to the molecular scale of this, then you can be like, oh, that's what it's made of. And what if I change it and zoom out? How does it affect the real world, right? So obviously, very long way. That's like eventual, maybe 30, 40 years from now. But that's where we're at.
So given your time frame, like how long you've been around and how many headsets you support, I'm guessing you're using Unity.
Yep.
But I was wondering if you could talk a little bit about the tools underneath and how you found them to be suitable for this kind of work and where their shortcomings were?
Yeah, so, when we started in 2014, 2015, we had the debate of Unreal versus Unity. And at the time, we chose Unity simply because of the much more abundant documentation. Like at the time, there wasn't as nearly as much documentation as Unreal. And so that's drastically changed in the last couple of years, and like you'll find great documentation on Unreal. And so I think it's one of those things where, we have like an existing code base that's pretty massive, and we chose Unity then, and that's why we're kind of doing that now, and we kind of learned to live with it. Is it the best thing? Can we choose something better? Maybe, but like, given that we, are constantly in talks with our customers to add different features and stuff like that, it's not something that we could quickly do right now. So maybe if somebody wants to donate $100 million or something, or we'd be more than happy to do that. But as a startup, we got to choose our battles, and that's not one that we want to take right now. So.
Huh. You may know there are 2 caves here in Cambridge.
Oh, nice.
One at Pfizer, one at Biogen.
Mm-hmm.
And there have been visualization studies for molecular design going back some years.
Yep.
Were you able to leverage that to get started?
Yeah, so one of our professors is out of UC San Diego. So one of our advisors is a professor out of UC San Diego named Jürgen Schultz, and he does a bunch of work with proteins and cave systems. And so he was actually critical to our success in the early days, because he gave us a bunch of advice on how we should be thinking about 6-off controls and things like that. In terms of kind of the I would say it's kind of interesting right now talking to these pharma companies, because a lot of them will, like Pfizer and Biogen, have these cave systems or have used cave systems. And unfortunately, a lot of the feedback is, we use the cave system, it was all right. We're gaining more value out of AI because they can produce X many molecules that may or may not work or whatever. And that's something that may or may not go to the clinic. And so a lot of the mentality is substitutionary. Is it 3D glasses or AI, right? And we're like, no, but you can't do engine or wheel, right? You have to use both, right? And so, or you should use both. And so, we are kind of in that sense fighting kind of an uphill battle with a lot of those kind of those who have that mindset. But a lot of people really, as soon as they get it, and they're just like, this makes sense. I need 10, right, or whatever. So.
Right. You're not expensive enough. You need to charge more. So.
Yeah, because the cave systems are millions of dollars, right?
Right.
Yeah. That's something, it's funny. We get all kinds of feedback of oh, you're too cheap or you're too expensive. And it's well, we just want to get this in people's heads and hopefully get paid, right? So, yeah.
One more. I'm guessing that the FDA would see this as a research tool and not software as a medical device or anything like that. But I'm sure some of your customers must need to validate your software just like they would any other software tool as part of their process. And I wonder, are there things that your software can do to help them with their documentation and with their regulatory processes?
I would say no, because like you said at the first part, we're very in the early stage, and so we haven't really been exposed to the clinical side of things yet. But we do want to go into the clinical side of things. Our vision, if everybody has AR and MR headsets just like these, right, in 20, 30 years, I want to be able to talk to my doctor and be like, why am I getting prescribed this drug? And then he can pull up a hologram. It's wow, it actually works really well with your protein that you produce, right? So that's the conversation I want to have with my doctor that's powered by Nanome. And I think that's when we'll really need to actually need, clinical clearance and things like that. But yeah, I mean, for now, we haven't really run into anything like that. In terms of your topic about validation, that's absolutely true. That's one of the reasons why the Nimbus Therapeutics case study has helped us tremendously, because that was the first time when they said we were going to go path A, but then we saw something in VR and we killed it. We went to path B, right? And so, now that we can actually point to a case study like that, it's been really helping us out, because then they're like, yeah, see, this is a must-have and not just a nice to have. Yeah,
I got one more question.
Yeah.
in the entertainment side, Quest dominates in terms of sales for content. Do you see the same for this, for this research app, or is tethered PC still fairly dominant? For the user base?
Yeah, so if you asked me this question a year ago, it would have been different than today. And then if you asked me 2 years ago, it would have been different than today. So I think, generally speaking, PCVR, like Quest 1 kind of didn't cut it in just in terms of power. And, it's funny because we also see that on the entertainment side as well, where, Quest 1 sales was much smaller than Quest 2, right? So I think at first, until the Quest 2 came out, it was very much kind of PCVR centric. And when Quest 2 first came out, Oculus actually had a program called Oculus for Business. And that's what really enabled us to, get a lot of traction within the enterprise space. And so we started to see a pretty big uptick in Quest 2 adoption. But then they got rid of Oculus for Business in the last, since the last Connect that they had at the end of the year. And so now, actually, in the last, I would say 6 months or so, we've been seeing a huge uptick in Bifocus 3 adoption. Wow. Yeah, because it satisfies all their needs, and especially these compounds are worth potentially billions of dollars, and so VPN access is a huge deal to these companies, and Quest does not support that, and so and Bifocus 3 does, and so when usually when we talk to our customers, we're like, okay, cool, they want to buy it, awesome. Which hardware do we pick? And we're like, well, and the saying goes for us is that we don't have a recommended hardware. We have a reason not to recommend each piece of hardware, right? So Quest is the best bang for your buck, but it requires Facebook login. It doesn't have VPN. Focus 3 is 4 times the cost, but it has all these enterprise features. And so some smaller biotech companies and startups, they don't really care about the Facebook login and the lack of VPN, and they'll still go with the Quest 2. In terms of PCVR, Windows Mixed Reality HP Reverb is kind of the most popular one, and then after that is Index, and then Vive Pro is probably ranking on that side. Yeah.
You mentioned that there was being able to crash a room with somebody.
Yeah.
Is there how do you mix that with these enterprise folks who want to be able to keep things private? Is there a setting? Do you make a private room? Is it a little checkbox or whatever?
So with the top pharmas, it's all on-prem deployment. So they don't even get access to the actual metaverse, if you will, which is actually kind of interesting because they're kind of making their own metaverses, right? It's the Novartis metaverse, right? And then it's the Roivant metaverse, and then it's it's shut off from the rest of the world, and that's how they also protect their intellectual property and things like that. And then we have also kind of a cloud deployment where you can it's more like traditional SaaS where we host their information, they access our metaverse, if you will, and then you can kind of it's kind of like a WeWork where you can see other customers, but you can also turn that off and make sure you hide it from them. So it is interesting because I feel the introduction of the term and idea of metaverse has helped us understand more about how we ought to be thinking about these spaces. And so that's been, I think, a really interesting thing in the past 6 months or so. Cool. So I think if there's no other questions, we got some headsets. I'm sure people have brought their own headsets. We could all jump in. So we have 2 other people from Nanome, Carla, who's our application scientist, and Edgardo, who's our chief experience officer. And so feel free to bother them and to ask some questions about sciencey stuff. One of our featured workspaces is actually the COVID MPro, which is the protease that is unfortunately responsible for wreaking havoc in people's bodies. And so you can check out that protein in Nanome. And so that's one thing. And then, there's also other things that are related to, cancer, Alzheimer's, a bunch of different types of proteins that are related to different therapeutic areas. So yeah, feel free to check it out. And thanks again for having me.
Thank you.
Thank you, that was awesome. Just super quick announcement. Nanome was kind enough to get us all pizza. It is delivered and on that table, so please feel free.
All right.